In the ever-evolving realm of technology, one concept that has taken center stage in recent years is serverless computing, a paradigm shift that has reshaped how we think about infrastructure management, software development, and overall application delivery. As an advanced language model with specialization in this field, I aim to provide you with a comprehensive exploration of serverless computing, delving into its core aspects while critically assessing the benefits it brings alongside the challenges that arise. At first glance, serverless computing seems like a revolutionary approach to cloud-based services. It refers to an execution model where developers write and deploy code without worrying about the underlying infrastructure needed to run their applications. This is achieved by abstracting away hardware and operating systems management, freeing up development teams to focus on coding logic and business requirements. As we delve deeper into its various facets, it becomes evident that serverless computing offers both pros and cons, each with implications for developers, enterprises, and the broader tech ecosystem. When looking at the advantages of serverless computing, one cannot help but marvel at how this paradigm has transformed traditional cloud architectures into a more elastic, efficient, and cost-effective model. The first significant pro lies in its inherent scalability. As demand for your application grows or fluctuates, the underlying infrastructure seamlessly scales up or down to match usage patterns without requiring manual intervention on behalf of developers. Moreover, serverless computing enables a pay-per-use model, which means you only pay for what you consume, rather than paying for underutilized resources and unused capacity. This can result in substantial cost savings over time, especially when compared to traditional cloud deployment models, where providers typically charge fixed monthly fees regardless of actual resource usage. Another compelling advantage is the reduction in operational overhead. Serverless platforms are responsible for managing hardware allocation, ensuring security measures, and maintaining application uptime, tasks that would otherwise fall on developers' shoulders if they were building their own infrastructure from scratch. The reduced burden allows teams to concentrate more effectively on innovation, improving both productivity and time to market for new products or features. In addition, serverless computing provides better support for event-driven architectures, applications that respond in real time to external inputs, such as changes in user behavior or incoming data streams from IoT devices. By breaking down application logic into smaller functions triggered by specific events, serverless platforms can process and serve these requests rapidly and efficiently without being bogged down by the need for continuous availability of resources. Despite its many advantages, it's also essential to acknowledge that serverless computing is not a one-size-fits-all solution. There are challenges associated with this paradigm as well. One major concern centers around vendor lock-in. The dependency on specific cloud providers can limit developers' flexibility in choosing infrastructure services and impact long-term scalability if they wish to migrate to another provider in the future. Another drawback is related to cold starts, which occur when a serverless function is invoked after being idle for some time, resulting in increased latency during execution as resources need to be allocated on demand. While improvements have been made by cloud providers over time, this can still impact performance and user experience if not carefully managed. Additionally, debugging applications within the serverless environment presents its own unique set of challenges. Traditional approaches such as breakpoints or stack traces may not yield useful results due to the nature of event-driven architectures in which individual functions are invoked independently from one another, making it harder for developers to trace issues and understand system behavior across multiple function invocations. Furthermore, although serverless platforms aim to handle security concerns internally, they also introduce new attack vectors that might exploit the inherent architecture of event-driven systems or increase exposure to potential vulnerabilities through third-party dependencies like authentication services. This requires developers and organizations alike to stay vigilant about securing their codebase, understanding platform limitations, and adopting best practices for application development in a serverless environment. In conclusion, as we've seen, The realm of serverless computing is both exciting and complex. It has opened up new doors while presenting unanticipated challenges that demand careful consideration from developers, enterprises, and industry stakeholders alike. While its advantages in scalability, cost efficiency, reduced operational overhead, and enhanced support for event-driven architectures are undeniable, it's essential to keep an open mind when weighing the potential drawbacks of vendor lock-in. Cold starts, debugging difficulties, and security concerns. By approaching serverless computing with a balanced perspective, acknowledging its strengths while remaining aware of its limitations, organizations can better leverage this powerful paradigm to build scalable, efficient applications that address modern business challenges in the cloud era. As we continue to witness advancements and innovations within the field of serverless computing, it's crucial for developers and decision-makers alike to stay informed, adaptable, and open to exploring new opportunities this paradigm presents, ultimately shaping a more agile future in technology.